All right, good morning, everybody. Hope you didn't stay up too late last night, because we got a lot of code to show today. My name's Hann. I work for Pivotal. One of their JavaScript barbarians. Actually, I'm the only one that calls myself a barbarian. I'm also co-lead on the Cujo.js project. It's the architectural toolkit for JavaScript. And today we're going to be talking about Pragmatic JavaScript. So of course, why are you guys here today? I mean, there's two words in the title today, one of them being pragmatic. So I assume that means you guys want to learn something very useful, something you can apply today. Hopefully I'll give that to you today. And of course, you want to learn more about JavaScript. I'm sure a lot of you have already tried it. Actually, I hope you have. Maybe you tried it and you didn't quite know how to use it. Someone didn't tell you. You weren't supposed to do it that way and you got burned. Or maybe, you just didn't know the right handle to push. You didn't quite understand how to make JavaScript do what you wanted to do. So, but let's get one thing straight. JavaScript is different. It's not Java. We know that already. It's not like a lot of the things that you're probably used to using already. So I came from a very strong Object Pascal background, and so I hit some of these same issues. Not the exact same issues you hit, but a lot of them. So first, I was like, oh my God, this sucks. I can't do anything. This is all wrong. It's riddled with all sorts of holes. And after many, many years of learning this the hard way, learning JavaScript, because I didn't actually take a course, I just went into the trenches, and I've been working on JavaScript actually since 1996. Eventually I was like, well, this actually isn't as bad as I thought it was. And actually, with the new changes in the languages, I actually like JavaScript now, and I think it's actually a decent language. So hopefully by the end of the day today, you guys feel brave enough to call yourself an expert, or at least to get down the track to actually becoming more proficient in JavaScript. So let's start at the basics. One of the big differences between what you're probably used to, I'm just guessing, how many here have a strong Java background? I'm guessing that's going to be just about everybody. Does anybody else have a strong Ruby background or anything like that? Okay, good. All right, so there's some people who are at least a little bit not forced down the Java way of thinking. But the biggest thing, I guess, to me is the fact that JavaScript is a functional language that's pretending to be object-oriented. And so it's this understanding of the functional aspects of JavaScript that is really going to help you understand more the JavaScript-y way of doing things. So, of course, we all understand what a function is. If you're not, you should be headed to a different session. But I did want to call out that I'm going to be talking a lot about function statements and function expressions. And in layman's terms, the difference is a function statement is more what you're probably thinking of with a function. It's a declaration of a function. Got the keyword function, a name, some parameters, squiggly brace, body, and squiggly brace. Where a function expression is a function that you'll find used like it was a variable or basically as a reference to a function. So I'm going to be using these terms interchangeably, so I just want to get that up front. So as with other functional languages, JavaScript treats functions as first-class objects. They're just things that you can work with. It's not just a declaration. It's actually, as you can see here, some examples. It's actually something you can get a reference to. You can point a variable to it. You can make it a property of something. It itself can have properties because, again, it's just an object in JavaScript. And very importantly, you can use them as parameters to a function. And you can actually use them as a return result from a function. They're just regular variables, regular things in JavaScript. So let's talk about scope. JavaScript is lexically scoped, which basically means that anything that I can read as I'm looking outward is something that's available to my scope. So function inner here, which is inside function top, has access to both the variables in top and anything that's enclosing top. So So that if we were to execute function inner, which actually is being executed by function top, then we've got access to all the variables in, in all of the scopes surrounding us. And those scopes are defined in JavaScript by functions. We don't have block level scope, we just have function level scope. So something like this is probably going to trip many people up in the beginning. And you can see here I've declared variable I twice. In this small snippet, obviously, it's very easy to spot this problem, but in a larger section of code, you might not see this. And so variable I is effectively hoisted to the scope of the function. It's not blocked to this for loop here. So effectively, when we return from this function, I is going to be set to 10 and not to 20, as we might expect. So this is something that might trip you up, and very important to understand this in JavaScript. We do have a solution for this. I'll get to that later. Oh, no, I'm going to get to it now. EcmaScript 6, which is supposed to be finalized hopefully by the end of this year, introduces the let statement. And the let statement introduces block level scope into JavaScript. So we do have a solution for this. But in the meantime, practically, you just have to keep in mind that JavaScript hoists everything to the function. So here's an example of me taking advantage of the fact that everything is hoisted. Here I'm using some variables a, b, and a function called add before I'm even declaring them. As you can see, I'm declaring them at the bottom. With functions, this is okay. I think most of us have been trained to understand that functions have more of a larger scope than variables. Variables are very procedural. You have to do things with them in a certain order. But to my JavaScript eyes, this actually looks like an error. It looks like I've accidentally declared some global variables, because that's what JavaScript's going to do if I forget to introduce the declaration for these. I guess back in the 90s, Brendan Ike, and the team decided that they would rather not throw lots of exceptions and rather try to do the smartest thing, try to guess what the developer intended to do. So they, in order to avoid as many programming errors as possible, they made all these types of decisions. So again, functions can be properties. And in this case, I've got an object, and I'm assigning a property to it that is a function. I'm just calling it method here. So in this case, you also see that we're referencing, this variable. This function has a context. So that when we call object.method, this function will execute in the context of this method. But what happens if we get a reference to method and then call it directly? What happens to this function? What happens to the context here? It's probably not what you're expecting. Function context in JavaScript is dynamic. It is not static. It's not how you declare the function. It's how you use the function that the context is determined. This is one of the conflicts between object-oriented programming and functional programming. Functional programming, this dynamicness, it's not an aspect of all functional languages, but it's an aspect of the dynamic functional languages. So here we have a function, just any old function declaration, and it declares, it references this thing called this here. So what is this here? We don't really know. But as soon as we add useful to this object right here, it still doesn't actually have anything. This still isn't anything that we can put our finger on. But as soon as we invoke useful, which I've basically named as a property on my object, as soon as we do this, this function now has a context. And this actually means something, and it points at my object. So this dot operator in JavaScript is what actually applies the context to the object, to the function. So what is this then in some random function that's not being operated, it's not being evaluated in a context? In legacy environments, and in just about every environment in use today, it's going to be the global object. In a browser, that would be the window. And again, this was a way to try to prevent lots of exceptions throwing up in web pages. In a strict environment, which you can invoke with the useStrict directive, this is undefined, and this is probably what we really want as programmers, because we want to catch these errors now. We're not in the days of the script kiddies anymore. So interesting thing about useStrict, and that undoes a lot of these early decisions to try to avoid errors. It undoes that and allows us as engineers to write code that we expect to fail early. So to use useStrict, you would put it at the top of a function. Some browsers don't care where it is in the function, but some do, so you should always hoist it to the very beginning of the function. You can also put useStrict outside all of your functions, the global scope, but don't do this. This has burned many people. Because if you have any third-party scripts on the page that aren't expecting strict mode, they will fail. And so I encourage you to learn more about strict mode. I use it a lot. Here's a link here. I got some links at the end as well. So because it fixes a number of those problems that were introduced from the early days. Okay, so the dot operator is not the only way to ensure that a function is called in a specific context. There are some convenience functions in JavaScript to allow us to do that, and they're actually properties of all functions. So all functions have in their prototype a call function which allows you to execute a function in a particular context. And you can pass arguments to this call function as well to provide arguments. So it's just like you use the dot operator, context.myfunc, but you don't actually have that syntax. I think this right here, the lack of knowledge that this existed was the number one misuse of the eval statement in JavaScript. So another convenience function is the apply, which works exactly the same. You give it a context, but instead of supplying the arguments directly in the parameter list, you give it an array of the arguments. So, and in ES5, thankfully, we have the bind statement. And the bind statement is a little bit different. Rather than immediately evaluate the function, rather than execute it immediately, the bind statement actually creates a new function for you that allows you, when that's executed, will execute your original function in the context that you've given it. So this allows you to then pass around a reference to something that you know is going to execute your function in the correct context. So I know there's a temptation to turn around and do that to every single function that you've got on an object, but that's really not necessary and actually probably has performance overheads. But here are some good use cases for it. I'm using a little bit of Node.js here. I'm accessing this module in Node.js called FS. It's the file system module available in Node. And I'm using the stat function here. And the stat function takes two parameters. It takes a file name, file path, and it takes a callback function. So, but I want the callback function to call a function called handle on my handler, which is an object. So how do I get it to call my function? Well, the easiest way in ES5 environments is to just bind A nice way to think about this is to think that I'm binding my function, but actually in reality what's happening here is I'm creating a new function that's going to execute my function in the right context. So, but I like to think of it as like binding the function together. And effectively you can think of it that way and reason about this correctly. So, but essentially what bind is doing something similar to what we have down here. And this is an example of not using bind, using ES3 syntax. What we're doing instead here is using an anonymous function expression in here as our callback to stat. And inside our expression, we're using the fact that within our scope of this anonymous function, we've got a reference to my handler, so we can just use we're using the apply in this case to apply to execute my handler.handle in the correct context and pass through arguments from function. Now let me get to the next one before I explain why we have to use apply here. And then here's a third example where since we know the parameter signature, we know the API of stat, we're mimicking that API here, and then just again, because we have my handler.handle in the context, we're just calling directly, and we're using the dot operator here to enforce the context, to bind the context on our function. So what's interesting about this one is if you know the parameter signature and you know it's stable, this is a very efficient and fast way to perform this. If you don't know the function signature, well, actually you need to know the function signature, but if you don't want this particular code, this code somewhere is probably in some sort of compositional layer. It's connecting my stat handler to this, this FS stat in this code. You may not want it to have to know what the function signature is, because then that's more code that you have to worry about maintaining. This is very useful in that application because you can just use the built-in arguments variable in JavaScript to just pass through the arguments, and you don't have to worry about keeping the signature in sync. Okay. So one thing you're going to see an awful lot in today's JavaScript is something called an immediately invoked function expression. So we call it an IFE because we don't like saying words. And all it is a function expression that is immediately followed by parentheses. And parentheses, of course, is what tells a function to execute. We also have some additional parentheses around it, and that's to disambiguate this parentheses following a brace in JavaScript. So it basically what we're saying here is that we're indicating to JavaScript that this is an expression. By putting the parentheses around it, JavaScript now expects to, it's looking for an expression at this point. And so it immediately recognizes that this is not a function declaration we're trying to create. This is a function expression. So there's other ways to tell JavaScript that you're actually in an expression. There's just any number of operators you can put in front of the function, but don't do this. I've seen plenty of people get confused for minutes or longer. So let's take a quick example so you understand why this might be useful. So this is the number one reason why we use a function expression here, and that is to not leak globals. Maybe we've got some global code. We can't help it. We need to write this code out in the global scope. An example might be to asynchronously load a script file. So in this case, we've got a function, an IFE here, and we're actually passing some parameters to the IFE. We're passing something called doc and something called global. And so where we're invoking this IFE right afterwards, we're passing in those things. So in this case, we're just passing in two globals. In a browser environment, this is equal to window, which is the global object. And effectively, what we've done is kept this variable from polluting our global namespace. So here's an example of using a function in a very functional manner. This function debounce, as you can see, returns a function. And what's very interesting about this is that this inner function here has within its scope handle and func and msec, milliseconds, and can use those as it sees fit. So we're going to get into this a little bit more detail later to see why this is really interesting. But
just going back to the iffy for 1 second.
Yep.
There's several libraries like jQuery, for instance, they use iffy all the time. Is that a bad thing then?
Is it a bad thing to use iffies? No, it's not a bad thing to use iffies. It's a code smell to me if there's a lot, because you're writing a lot of global-ish code, and that's kind of a code smell to me. But iffies in themselves are not bad. They execute once, typically. So.
I think on your slide you were just talking about the syntax of it, with the plus sign.
Oh yes, that syntax with the bang and the plus. Yeah, that just ends up being confusing, I think, to most people. So the syntax with the parentheses is much more clear, at least to me it is. So here's just another example of some interesting JavaScript that you'll see a lot, and this uses an iffy to create and return a function. So here we're creating something called create, and if we're going to borrow something that exists in an ES5 environment, if we're in an ES5 environment, otherwise we're going to provide a shim. And you can see this function that's providing the iffy is capturing this parameter called base, and we're providing just this function expression here. And then our function that we're ultimately returning and is going into this variable create can use base as it sees fit. So I threw some stuff at you, and I was trying not to talk about these things, but effectively what I've been showing you the past couple of slides is something called closures. And closures are basically, well, let me start by saying that functions have a scope, as we saw, and their scope extends beyond just the function itself. It expands up to several layers all the way up to the global scope. And this pair of function and scope together is what we call a closure. So you might hear a lot of people talk about just a function as a closure, but what they're talking about is it's not convenient to talk about this pair. So we often just talk about functions as being closures. And this MDN article, which I highly recommend, gives an awesome overview of closures. I'm going to do a little bit on it here, but they may actually make the same mistake, and they call a function a closure, which is fine. Okay, so closures. Every function actually creates a closure because every function has a scope, and every function executes somewhere, and there's going to be some sort of global scope, and it's going to be capturing some sort of scope somewhere along the lines. So in the terminology we use when we're talking about closures this is the same example I showed with function scope, is that this inner function actually closes over the scope of top and closes over this whatever scope is above top here. So, and similarly, top closes over whatever scope is above it. But this isn't that interesting. It's just different terminology. But where closures get really interesting is when you return something out of these functions, return a function out of these functions, return an object that has functions out of these functions, and use them outside of the original place where they were declared. That closures get interesting. So for instance, here's a very silly example. If I were to execute top, which returns me a function called inner, so func down at the bottom here now has a reference to inner, and then half second later, hours later, days later, I call inner, what's going to happen? In a statically scoped language, we'd probably expect some sort of null pointer exception. But because function invocations are paired with this scope, that this is all reference counted, and this scope will stick around until this function invocation goes out of scope. Sorry, you had a question.
I thought I had an answer to your question. So it's going to get a snapshot of A, right? So later on, the function's called A is going to be 42, but if something outside changes A,
Yeah.
it's going to keep the snapshot.
Okay, so he's asking whether or not it's going to get a snapshot, and I used to use the word snapshot. It's totally not the right word, because it's a snapshot. If you're thinking of a snapshot of the scope, that's incorrect, because the scope is still alive. So if you're exporting two functions, right, and one's manipulating the scope and the other one goes to read it later, it wasn't a snapshot. You're going to get the current value. You're not going to get a snapshot. So again, closures are a pair of the function invocation, which I neglected to say earlier, function invocation and the scope. And the scope is active. It's not a snapshot. Thanks. So, but here's the bad part, and this is exactly the situation that we're referring to here, is loops and closures together are going to get you. They've gotten me dozens and dozens of times. Not recently, luckily, but I think it's also, thanks to my IDE, it actually warns me about these. So in this case, we've got what looks like very benign code. We're just this function create combo. It takes some method to create something and notify something and some data. And it looks like data is an array. And we're collecting these things called notifiers, and we're eventually going to return these notifiers. So we just loop through this data. We create this thing using this create one, using some of the data, and then we push onto an array a function that ends up calling notify. So seems pretty benign. Does anybody know what the problem is with this code? There's actually two problems with this code. JavaScript folks cannot answer. Okay, so I'll answer here. One is we made the classic mistake. We declared var thing down here in the block, okay? But it's not a block. It's not block scope. It's function scope. So var thing is actually at this scope out here with the array, okay? So we're really just reassigning thing down here every time we create a new one of these things. So thing over here is always going to be the same thing. It's always going to be the last thing. And this is also a problem because, even if we did put thing out here, it would still be the same problem because all of these functions that we're returning outside of this create combo are all going to refer to thing, and thing is just going to be the last thing it was assigned to. No, but it's passing the reference, but the reference is being updated here every single time. So we're creating all these functions in here, and these functions all are closing over thing, but thing is really declared at this scope. So how do we fix this? There is a way to fix it in ES6. I'm not going to show it to you. It's just teasing you at this point. But here's how we fix it in an ES5 type environment right here. So the easiest way to do it is to actually create another closure. So if we've got a mapping of closures to things we're interested in that's one-to-one, then we've got one closure per thing that we're trying to capture. That actually fixes the problem. So here you can see we're actually declaring var thing as we were before, but we're doing it inside of a function this time. So this function right here, when it is created, it's going to close over. Well, it's actually going to have a local variable to thing, so that when this function executes right here, sorry, this is the one that closes over thing, and there's a one-to-one relationship, as you can see, between this function and this thing. Does that make sense? That's very important. Just it comes down to the scoping, the fact that we've declared another function, we've got a new scope, and now we have a one-to-one relationship between thing and the function that's getting exported.
So before in the loop, it wasn't creating a new scope each time.
Right. Right. This is just, they're all sharing the scope from create combo.
Would another solution be to, back up the slide, sorry. Would another solution be to call create one data I within the push call?
Within here?
Yeah.
Yeah, he's asking if instead of thing here, create one parens data sub I. And the problem there is that I is shared. So that will not fix the problem. So yeah, I tried that once, you know. I'm sure I tried that like 10 years ago. So okay, so there's no way I could explain all this stuff. This is an awesome book. I don't like any JavaScript books, but I love this one. So I got another link to it at the end. David Herman gets into this, and definitely read it. So, okay, so let's jump into inheritance. So JavaScript, we say, is prototypal. And in prototypal inheritance, basically, we're creating copies and we're specializing those copies. All right, that's the way it is in the theory. That's the way it is in true prototypal inheritance. In true prototypal inheritance, we have a parent, and we can directly beget a child from that, and from that we could directly beget a grandchild, and we can specialize these things, this child and this grandchild, as we go along. Prototypal inheritance in JavaScript is not true prototypal inheritance. In JavaScript, we can have objects. Oh, sorry. I'm showing true prototypal inheritance in JavaScript. In ES5, we actually do have true prototypal inheritance, and it's done with the object.create method that I showed before. So it allows us to directly descend, you know, from a parent object to beget a child object. And you've probably seen this on some of my slides. There is, if you're interested in providing shims for ES5 and some of the legacy browsers, we've got a great library for that. Excuse me. Okay, so JavaScript is not truly prototypal. It's kind of quasi, somewhere between object-oriented and prototypal. And the reason for this is because Java was very popular at the time, and the team decided that they needed to make this even more JavaScripty, more Java-like. So they came up with this concept of this quasi prototypal inheritance. So in JavaScript, we create these types, big quotes, which basically are just a constructor prototype pair. So we have this constructor and a prototype that we join together, and then we use the new operator, which actually constructs this prototype chain so that things can inherit from other things. Okay, so and just by using the new operator itself, an instance that comes out of this constructor actually does it inherits from its constructor's prototype. So there's an inheritance chain just by calling new. So syntax is pretty simple. I'm sure you've seen this all before. Okay. So inheritance of these types happens the same way. So since we've got the ability of a constructor to be able to chain an object to its prototype, we use the same mechanism in JavaScript to do the inheritance chain for multiple levels. So a child would descend from an actual instance of a parent, which, as we'll see in a second, becomes the child's prototype, and that in turn would descend from the parent's prototype. So here's an example of how that works. We've just got a parent constructor. We go ahead and create a prototype, decorate as prototype as we see fit. Then we can create this child constructor, and the child's prototype is basically a new instance of the parent, and this is how the prototype chain is supposed to be set up in JavaScript. And then, of course, continue to specialize this prototype of the child. So, and just adding the additional note here that every user-created object actually descends from object.prototype as well. So constructors have some additional benefits. You can provide some initialization parameters, do some initialization code, and they also provide this additional benefit of being able to hide some implementation details because prototypes are out in the open. They're basically everything on a prototype is public. Of course, we've used some conventions as well to say that, okay, everything in my prototype is open to the public, but don't use this one over here. I put an underscore in front of it or behind it to say that don't use this. And so I call those protected by convention. But we also can create another two classes of things, and these are privileged functions and properties. Functions, and then we can have these private things that aren't really properties, but we'll see in a moment that we actually have the ability to create some private stuff. And again, this is done inside of the constructor. So inside the constructor, we can do stuff like create this variable called secret, and because it's declared as a local inside of this function, it's not available to the rest of the world. However, we can create a function inside of the constructor that has access to it because it's within the scope of this function. So if we then expose this function on our object that we're creating, we've basically created this new class of functions that are privileged. They have access to this private information. So, but unfortunately, we can't inherit any of this private stuff or privileged stuff directly through prototype chaining. So what we do instead is we call the super, and the way that's done in JavaScript is to just take the parent constructor and apply it and pass the arguments. Or in a function, we can just call the parent prototype directly and use the apply syntax. So then once we've done this, I'm going to point out this new variable get here. Because the parent constructor was executed to do this prototype chaining when we declared our child constructor and prototype, this get actually gets added into the child.prototype. So this is kind of weird. This get, what does it do? Because it's at the prototype level. It is a prototype now, and it doesn't really have access to those inner private variables that we had. But fortunately, if we called the super gets executed again, and we end up with another get on the instance itself that fixes that for us. This is just kind of gross, especially since what if we were passing something into the constructor and we're using that thing? What happens now? When we do this prototype chaining right here, when we're constructing our parent instance to do the prototype chaining, we're passing an undefined in here. What happens in here? Now we've got to write our constructors in a way that, number one, we have to make sure we're not going to fail, we're not going to throw, and we also have to write them in a way that makes sure that we're actually going to be handling the case where we might not have been passed parameters. This is gross. So this is just summarizes it that we've got this get that's broken, may even throw if we didn't code correctly, but then we kind of patch it over that with something that actually works, and that's Grumpy Cat says that's just horrible. We need to fix that. So an answer to this, one way to fix this is with true prototypal inheritance. The way to do that is using direct prototype chaining. Instead of creating instances, we use true prototypal inheritance in order to just to avoid the constructor altogether. So in this case, let me back up. This is what our prototype chain looked like before, and this is what it looks like now. We're using object.create to create the child prototype as a direct descendant from parent.prototype. But we now avoid calling the constructor. But we can still call the constructor in our child constructor by applying the parent constructor as I showed. So there are a couple other use cases for true prototypal inheritance. Actually, we end up using it a lot. I don't expect you guys having a classical background. You're probably used to working with objects that are declared with constructors. But there are still some uses that you might find to use object.create. Here's a simple example. Got some function, create bindable view, that takes this hash map of options, basically just an object literal. And I want to fill in some gaps, some defaults, and then pass that on to something else. Rather than pollute this thing and fill in the missing properties, I'm going to create a descendant of it, decorate it, and then pass it through. So that's I use this pattern a lot. Again, I'm not getting a commission from David, but definitely read David's book. He goes into this in quite some detail. Okay, I think the last mental hurdle, for me, when coming from a more classical environment to JavaScript, was getting used to async, because in JavaScript, of course, there's no real concurrency in JavaScript. Things happen in parallel, and there's multiple threads happening, but in our code, in our environment, we only have one thread. So how do we deal with that? How can we possibly handle all of these things happening at once in a single thread? And especially since the language itself has no formal mechanism to deal with this. Well, this kind of happened by accident just because JavaScript started in the browsers, and the browsers were built around a global event queue. So it turns out that if you've got this global event queue and you ensure that the handlers that are servicing this event queue all run to completion before the next handler and before the next event is serviced off the queue, it all just kind of works out. So now this is has finally become an official part of the language of the spec, that this is the preferred way to achieve this multiple things happening but only one thread of execution. And the obvious way in a functional language to deal with the fact that some things might be happening now, but we might want some things to happen later in a later turn of the event queue, is to use something called continuation passing. Because we have first-class functions, we can pass them in or pass them out of functions. We can pass these functions around to get executed later. So this became the number one pattern in JavaScript. And so the pattern, you see this all the time. I showed an example earlier. I was passing in a function that created something and passing in a function that needed to get notified later. You might be passing in functions to get progress events. You might pass in functions to get notified of failures. So what's that look like? I mean, it's simple. You've all seen this before. Here's a typical XHR type solution, abstraction, passing a type, passing a URL, passing a callback if the XHR was successful, passing an error back if it wasn't. Eventually, sometime later, a callback or an error back is going to get called. I mentioned quickly in the slide that sensible callback implementations will always call back asynchronously, and the reason that I call them sensible is because you can always write code knowing the order that things happen in. So in this case right here, it should log getting before it logs got it or I has a sad. In early versions of Internet Explorer, XHR doesn't actually work this way, so that's lots of the XHR implementations actually fix that for them. So what's wrong with continuation passing? Number one thing is results are no longer returned from functions. In a functional language, that's very important. We want to compose functions. We want to be able to call a function and chain it to another one, and that's just the model that we're used to. We no longer have that model, but and then we end up in this never-ending cycle of passing callbacks down into functions, and any function we want to use now in this async operation now needs to accept callbacks, and it just becomes this callback hell, and it gets really messy. So here's an example right here where I'm trying to provide a layer over my XHR, and it does two things. It pre-provides the get parameter for me, and it also tries to do this little bit of help around my XHR in case the invocation of the XHR, the synchronous part of it, fails. So I've got some code now, and again, I need to keep passing these error backs, and I need to propagate all this stuff, and I'm not returning anything from this function. So here's an example with fallback. I know you probably can't see that. So now what I'm trying to do is emulate this try, catch, finally in an async world, and that becomes really even more difficult because now I've got to handle this case. All right, if something happens, actually I'm doing a little bit of validation, sorry here. If something happens, I want to try again, so now my code's getting a little bit more convoluted. I did pulled out some functions to try and reuse them. Here's another example where I'm trying to coordinate two XHR posts, and I need to just return a success if both of them have succeeded. The way that this is done with callbacks is always with a counter. Dave Herman gets into this in his book as well. And his recommendation is to use a counter here, to always count, and then because one of these might fail, but the other one might succeed afterwards, I have to check to make sure we didn't have a failure first, before we call success. And this, all I'm trying to get at here is that this is starting to get more complicated. And then when I tried to add rollback here and try to do try finally and stuff like that, this just becomes reams and reams of code. I mean, the code for this was at least 6 times as much code as I had on the previous slide. And Grumpy Cat says, no, this is not going to work. So is JavaScript doomed because of this? And no, dig back in history, and of course everything was invented in the 70s. So dig back far enough, we can find that we can use something called promises. So promises eliminate continuation passing, and they allow us to reason about code in a sequential manner that we're used to thinking about. They even allow us to think more in terms of try, catch, finally. The syntax isn't going to be exactly the same, but we can structure our code and think about it in the same way. And they also allow us to return things from functions again. So the current standards for promises in JavaScript started from this seriously bright guy named Chris Zeit from Dojo. He defined them as thenibles with a single method on it, very simple API. Just if this object has a then method that takes callback and error back and potentially progress, and then returns another thenable. So these thenibles, we now call them promises, and they've become more formalized. There's an effort recently by Brian Cavalier and Dominic Denicola to revive these efforts to tighten up this promises specification for JavaScript because it was really loose and left a lot of the edge cases undefined. Promises A+, I've got a link for that, is the formal specification. It's gaining tremendous traction and may actually end up being in the formal language itself in ES6 and HTML5. So here's an example of promises in action. This is a very popular use case in my world. I want to show this busy indicator, which may be an asynchronous operation. I may have to go, fetch something from the server to show something on the screen. Just the act of showing it on the screen, because it might be animated, might be something that takes an amount of time. So this is asynchronous task called showBusyIndicator. Then afterwards, I want to go fetch some package off the server. Then I want to show this main view, which you can see here. And then I want to hide the busy indicator. So there's 4 asynchronous tasks I want to do. And rather than have all that crazy callback code and try to deal with what if something fails, I'm just showing the happy path here. But once we use promises, and these functions now return a promise, and a promise is basically just this I want to say guarantee, but it's this promise, and promises can be broken, but a promise that I'm going to return you something in the future. So by returning a promise, I can then call this then on the promise to then do something else. And if that returns a promise, this package, this AMD loader called curl will return promise-like things. Then I can call then on that, and then I can show this main view, which might be asynchronous, and then I can hide this busy indicator. And all these asynchronous things, I can list them at least in something that looks procedural now. And I can also start reasoning about things in some of the semantics I'm used to. So this code on the left looks like something I want XHR to look like. I want this XHR operation here to be synchronous, but it's not. It's async. So if I could write a try-catch around it, this is what I would do. I would say, okay, try to send it. If you can't, log an error, and then after you're done, clean up. Okay, but because this is an async, we can't put a try around it because the operation might happen sometime in the future. So I'm using a Cujo project called When, which is a Promises A+ implementation. And this, I'm using this special operation, which is common to a lot of the Promises implementation. I'm lifting r.send. I'm taking this callback-based send and turning it into a promise. And I'm using this otherwise method, which means if there was a problem, go log an error. And then after you're done with everything, clean up. And then if you notice, I'm returning this promise. So in the success case here, I'm returning just the result of this send operation. And in the error case, well, yeah, and in the meantime, I'm also doing this in sure. So anyways, I'm returning a promise that's eventually going to provide the result. So, and here's the other example I had using promises to do the fallback. But promises are a whole hour-and-a-half discussion into themselves. Some excellent tutorials. We've gotten really high marks on our tutorials on promises and programming in async, so I recommend that you visit this and check out the spec at promisesaplus.com. So I'm going to talk a little bit about modular because modules are key to my sanity when working with JavaScript. The benefits that I recognize out of modules is they help me think about my code in small chunks, makes it easier to think about, makes it easier to test. You guys know the benefits of modules. And of course, dependency management, something you don't really think about that much in the Java environment, but something that JavaScript developers painstakingly think about all the time. So let's take a look at a very common, very popular example today. It's called the module pattern, and it uses an IIFE. So we just declare an IIFE and pass into the IIFE some global object, something hanging off of the global. And I'm just creating it here if it didn't exist already, and pass it into our function. And then we can decorate this namespace with whatever we see fit. Here I'm creating just this thing called my module, and I'm decorating this namespace by adding a property to it called my module. So the problem, though, with module pattern is it doesn't do anything except remove globals. And actually, it doesn't. It just globs all the globals onto one name that we've reserved for ourselves. It doesn't solve problems, for instance, with this. Down deep in the code here, I don't know if you guys saw this, but there's this reference to a dependency somewhere else in the code. All right, and so just a quick scan of this, you didn't see that. Trying to create some intelligent build tool to discern this stuff becomes really hard to do. And also, once you've got multiple projects coming together, there's still a chance that these namespaces could collide in a certain way. There's no way with this pattern to alias or remap these. And then the whole task of dependency management gets really convoluted. I mean, this is basically verbatim, not verbatim, but I'm writing this practically from memory, from a project I worked on several years ago, just trying to put comments in the code that loads all this stuff in order to say, no, don't put this ahead of this because of this dependency that's way down deep in the file. And this is just not a solution, and Grumpy Cat says, yes, it's awful. So luckily, we do have formal modules in JavaScript. There are 3 standards today. The first 2 are de facto, and we will have an official standard. I'm going to talk about these quickly. Asynchronous module definition, AMD, was started by James Burke, another Dojo guy, back around 2009. It was started out of the Dojo's module system. They tried to come up with a better API, something that's not Dojo specific, something that's generic. And then later they coordinated with the CommonJS folks to try and get some cohesiveness there. It works in all the browsers. Works back to the Netscape days because it uses techniques that are known to work everywhere. It also works in Node.js. Curl works in there, and a companion project to Require.js, the most popular AMD loader, is R.js. So it also works in Node. Lots of implementations out there. There are actually dozens and dozens of AMD loaders out there now. Require.js and curl being the most popular. So quickly, let's just look at AMD modules. I'm going to show you some tutorials. I'm going to go. There's some tutorials on the web, so I'm going to go over this quickly. What AMD comes down to is this single global called define. And define says I am going to define a module. So I would have this file here, whatever it's called. It's probably some child of my module, it looks like. No, it declares. All right, this is confusing. Sorry. So imagine this says my child module here. Okay. Anyways, I'm pulling in. As you can see, I have 2 parameters here. First one is an array, and the second one is a function. The first one is a list of parameters, a list of dependencies, and the second one is a factory function. And as you can see, there's a one-to-one mapping of these dependencies to these parameters that are passed to the factory function. So it turns out that these strings here are IDs of modules. They use a syntax that's similar to CommonJS and is very similar to what you're probably used to for dealing with files. So this // means there's a peer module called myModule. And what the AMD environment will do will ensure that these modules are available, whether they've already been loaded or need to be fetched from some remote server, ensure that they're available before this factory function executes and passed in as parameters to the factory. So then we can use these variables as we see fit. Again, sorry about the code confusion here, but I shouldn't be reassigning this module. This should say something like my child module, decorating my child module. And then the important thing to do with AMD is to then return something from the factory. Return something that says, this is my module. So what I really, really like about AMD is that it's easy to discover the dependencies. Bang, they're right there at the top, the interface of this module. It also has lots of options and syntax variations, which I like. And it's got a lot of build tools available. And it actually has a lot of support in IDEs. I use scripted and IntelliJ, and the support in those is for AMD is quite good. What are the problems with AMD? Many find that boilerplate at the top to be very ugly, very verbose. If you're trying to write something that works in Node as well as AMD environments, the boilerplate gets even bigger. That adds some overhead to the size of the file, and we're very byte conscious on the front end. Actually, the fact that there are many options and syntax variations makes it hard to learn. You know, you're looking at all these different options for AMD, and sometimes you can use a factory function, sometimes you don't need to. Sometimes you can include an ID, but most of the time you don't need to. It just really gets confusing. And in its native form, it doesn't handle dependency cycles. I mean, just don't write circular dependencies. But So anyways, at the same time, or about the same time, CommonJS, the effort to make this common infrastructure that everybody could write to started, spearheaded by Chris Cole. And unfortunately, it said, we want a clean slate. This is how the JavaScript should be if we could write JavaScript. And so they ignored the needs of the browser because they were concentrating on server-side JavaScript at the time. So CommonJS modules, as you know, they're available in Node. Vertex has them. Ringo.js, which runs on the JVM, has it. Browsers typically you have to do some sort of build step. You can actually run them in the browser if you build them and convert them. Lots of people end up converting them to AMD anyways, which is great. I mean, you can author in what some people believe is a cleaner format and then transport it as AMD to the browser. And curl will actually allow you to author and transport and then just-in-time convert in the browser itself. So here's an example of a similar module with the same silly mistake with rewriting. Nope, okay, nope, I didn't make the mistake, yay. Okay, so in CommonJS syntax, we have 3 variables, one called require, one called exports, and one called module. Now these are free variables, they're not globals. They're just scoped to this particular module. There's some magic that happens so that they're injected into the environment just in time. Require is used to, as you could guess, go fetch a module. This happens synchronously. And then exports is just this thing. It is the embodiment of your module, and you just decorate it, and it automatically gets returned to the environment and to any other modules wanting to use it at a later time. So require and exports is what you'll see used in CommonJS modules. So again, I'm just decorating this thing. I've been provided this thing called exports. I just add properties and methods to it, and then it just gets released to the environment. So there's a Node.js variant to CommonJS. It's not in the spec, but most of the environments out there, I think all of the useful environments implement this. and they take advantage of the fact that maybe we don't want to use this object you gave us. We want to use our own object. And so the syntax for that is to assign the thing we want to export to this module.exports property. So we say this here, this is the thing I want to export. So I could export an object like I'm doing here. I could export just a function. I could export just a string. And so this is how you would do that. So there are still some pitfalls with CommonJS. It tries to do the right thing, but there's still some, because JavaScript is so dynamic, we can't prevent people from doing things like this. For instance, require function takes a string, but we could put at runtime decide, I'm going to give you this string or that string. What this does is it breaks the ability for any kind of static analysis tool, any kind of build tool from knowing what's going to be imported, or on the same token, what's going to be exported. So basically, without actually executing this code, you can't tell what this module actually does. So, but again, people like it. It's got a cleaner syntax. It's great authoring syntax. It's really clean. There's no boilerplate. It just feels like JavaScript. Very wide support on the server side. It is possible to run it in the browsers. It supports dependency cycles. You can actually explicitly write in a certain manner if you know you're going to be creating a cycle. And it also has great IDE support. The browser support, like I said, is either through a build step or an on-the-fly transpilation to AMD, so there could be a performance hit there. It doesn't quite eliminate the deep dependencies. As you see here, we could still have this hidden dependency that a build tool would find, but a human might not. And it relies on the synchronous require, which in a browser causes all these issues and why it needs to be transpiled or on the fly converted. And eventually, I mean, CommonJS is great, but aren't we working towards a standard? And the answer is yes. The official standard for JavaScript modules will be part of EcmaScript 6. They expect to have this spec finalized around the end of the year. It's going to enforce static dependency analysis and provide hooks for consuming all the modules we're creating today. So if we're creating AMD and CommonJS modules today, there'll be a way to pull those into ES6 environments. So I encourage you to not wait for the spec, to dig into modules now. But the big problem is that this is when we're probably going to be expected to be able to use ES6 modules in production. So that, or whenever Windows XP and IE8 falls out of your target user range. But again, author in AMD or CommonJS now, and there will be tools. I've already been working on some, and other people have been working on them. There will be tools to actually use, and the spec provides the hooks to use AMD and CommonJS and other types of modules in ES6 environments. Again, some great tutorials. We get lots of kudos for these tutorials. Go to no.kujojs.com and click on tutorials to learn about, in detail, all the different type of modules. I got some other links here. So, if you've mastered these things, modules, async, functional programming, and where it conflicts with object-oriented and prototypal inheritance, I think you're ready for expert mode. So I'm just going to quickly highlight some things. We do know how to document code. I had plenty of slides on that. It's called JSDoc, and it's very similar to JavaDoc, but JavaScript needs a lot more hinting because it's so dynamic and so flexible. So it's got some extra JavaScripty things in it. I definitely recommend this first link here. Again, it'll be at the end. We actually do AOP. There's going to be an awesome session at the end of the day today. I recommend everybody go see this session by Brian Cavalier, showing about how some of the things that we just showed here today allow us to do AOP without any kind of, bytecode translation, or of course we don't have the bytecode, but we don't have to do any kind of translation. It's just the features of the language that you saw today allow us to do AOP in JavaScript. Similarly, we're doing IOC. We have an IOC container called Wire. It's awesome. It's got a lot of useful features in it. Does a lot of the things that you're probably wishing you could do on the client side. Actually works in Node as well. RESTful patterns, yes, we've got an entire RESTful library. It's composable, it's very functional. It's called rest.js. We do enterprise messaging. Yes, we have data modeling. We actually have a Skunkworks project in Cujo as well called Cola to do this, but right now I recommend you check out the session with Scott, Tim, and Matthias, because I'm sure they're going to be talking about data binding and data modeling. All right, so I have 20 minutes, and I have lots of opinions and lots of information. So if anybody has any questions and wants to go back to a slide and ask a question, I am very happy to take questions now. The let. So the question is to go back to the slide that showed the let syntax. Context. Scope. I want scope. Okay. Here it is, right here. Uh, 20, yes, sorry, that's a mistake in my slide. Yes, thank you. Questions, yes? Sure. Client-side rendering versus server-side rendering. Whoops. Okay, here are the links that I promised. Client-side rendering versus server-side rendering. Very, very good question. Of course, there's that balance. How much do you render on the server? How much do you render on the client? And I think we're in one of those phases right now where we were doing everything on the server, and now everybody's saying, no, do everything on the client, and eventually we're going to come back to this happy medium. And in some ways, I think that's a necessary exercise to learn what the capabilities of the client are and what are the situations where you actually want to move some of that back. And it's something that we're actually working on within the Cujo.js team to try to write our data binding library such that, and our IOC container such that some of it actually could be handled on the server. So for instance, an initial page render might be done on the server side and then just hooked into on the client side. But then from then on, the client is in charge of repaints and redraws at that point. So I think we're all going through that next necessary exercise of going too far to figure out where to eventually settle. So I don't know if that answers your question, but that's my opinion anyway. So more questions? Let's see. Yes.
I don't really know too much about Cujo.js. Could you kind of just go over maybe a high level?
Sure. Actually, I'm going to bring you back to this in case people have written down links. Cujo.js is an architectural toolkit for JavaScript. It was started by Brian Cavalier and I back in maybe early 2010. We both come from strong engineering backgrounds, strong object-oriented backgrounds, and we both learned JavaScript the hard way. And one of the things that we felt was missing, or some of the things, were just these basic architectural level tools. So we both ended up in projects, and we would, be looking out there. That it was actually very hard to find projects back then because we didn't actually have package managers for JavaScript back then. There actually are some popular package managers now. But it was just really hard to find stuff. It was like these tools just didn't exist. So we started building these tools. We started working on module systems. We started working on IOC containers. Of course, with an IOC container and an async environment, you need something like promises to be able to think rationally about asynchrony. So we just started building up these tools, and then we've had other people join in, and lots of contributions from the community. And the major problem, I think, with the JavaScript community is that a lot of them are uneducated. They're not educated in classical techniques. And so we decided that we don't just have to provide the tools, we have to provide the guidance. And so that's why the tutorial site, the no.kujojs.com, got created as well. So, sorry, does that answer your question? Sure. Compare AngularJS and CujoJS. AngularJS is a very cool tool to do certain things well. I can't think of a good way to compare, but AngularJS is, if you write your templates a certain way with the tags in your template, and you write your code a certain way, you can achieve this architecture, which is somewhat minimal but effective for doing things. We take the opposite approach and say, here are these tools that are proven, time-tested, and proven. Angular kind of does dependency injection. It's a very specific case of dependency injection, and it does what it does really well. I'm not going to rag on AngularJS. I really like it. But we said, no, dependency injection is this broader thing that you should be able to apply to any code. So we work on a dependency injection tool, for instance. And we work on a data binding tool, for instance, that allows you to do data binding in several different ways. It doesn't have to use the exact format that Angular uses. So that's how I would compare the two, is that Angular is a very specific implementation of an architecture, whereas we provide tools for you to build an architecture. And there's a project within Cujo called Seed that just gets you a quick start into a very simple architecture, just makes a small app in a way that we prescribed as a good way to use Cujo. So, sorry. So yeah, Brian's saying the last half hour of the next session on JavaScript track is going to have, we're going to be talking about Cujo there, so it'd be a good place to ask some questions. Okay, sorry. I think we're up in terms of the amount of time, so thank you everybody, and I'll take questions up here afterwards.